Today I am going to begin new series of lesson. I am explaining how to draw the isomers for hydrocarbons. This belongs to the organic chemistry section. So this is the part 1 of a series of lessons. First we look what are the three types of isomers possible for hydrocarbons. There are three types we can define. First one, chain isomers. Under the chain isomers we can find branched isomers. Second one, positional isomers. Third one, functional group isomers. Here we are going to begin with chain isomers. Now it is required to have minimum number of carbons to find out different isomers. Let us start with most simple hydrocarbon, methane. So this cannot have any isomer because it has one carbon. So there is no any other isomers. When you come to the next one, ethane, we can draw the detailed structure. That one again no isomers. Then we will go to the propane. Again there is no any isomers. Then we will go to the butane. So this will show different isomers. So that means it is required to have minimum number of carbons equal to 4 to show any isomer. So the simple hydrocarbons, isomers are going to begin with this butane. So let us look how to design the isomers for butane. Now hydrocarbons just have chain isomers because they don't have any heteroatom. If they have heteroatom, then it is possible to have functional group isomers and positional isomers. But there are no heteroatoms here, so we focus only chain isomers. Now I am going to remove one carbon from this. Let us say this carbon and try to connect to here. I am not going to connect to there because it will result same thing. So then I am going to remove this. And also I am going to remove this hydrogen. So I am explaining this in this way. CH3. Now there are two hydrogen. Same thing. So this is to just explain how these atoms are connected. There are no any difference between this. Now I am going to remove the methyl group from here and connect here. Then I have to remove this hydrogen from there and connect there. Actually, it is a type of interconversion. So this is actually CH3 group because this carbon has already two hydrogen atoms with this hydrogen CH3. So we can write these are just explanation. So this is the one, this is the two. So then we can say butane has two isomers. Now we can name the two isomers. First one, it is a simple chain structure, so it is N-butane. Second one, it is a branched one, it is a 2-methyl propane. So there are two isomers for butane. Now let us move into the pentane, the next member of the simple hydrocarbon series. Pentane has 5 carbons and 12 hydrogens. So here again we will do the thing we did earlier. I'm going to remove this methyl and going to connect them. Then I can come to up to this carbon. So the hydrogen removed from there should be connected to this carbon. So this is the first isomer. Now if I am going to change the position of this methyl to here, then it will result the same hydrocarbon. So we will do that and check. Once it is removed, hydrogen should come there. So I am going to connect here, then that hydrogen should be removed. So now I can see in this there is ethyl part. There are 2 carbon fragments, it's called ethyl part. Here again 2 carbon fragment, ethyl part. So this CH3 part to the dash is available or is present here also. I am meaning this part. So it is clear now. This is the same hydrocarbon. So there's no point we shift the methyl group to here. Then what I am going to do is I remove this methyl and try to connect here. So that hydrogen should be connected to here. So then we got new isomers. So this part, it is a isopropyl group. There are 3 carbons, but it is isolatedly connected. The 3 carbon is not found in the main chain. So we will identify that as isopropyl group. So then we can say pentane has 3 isomers. So this is N-pentane, straight chain isomer. This is a branched one. This is again another branched one. Now let us see the nomenclature of these 3 isomers. First one, simple chain or straight chain. So we can name that as N-pentane. Second one, it is a branched one. So we can see methyl group is connected to second carbon in the chain. So 2-methyl butane. Third one, there are 2 methyl groups connected to the center carbon. So it is called 2,2-dimethyl propane. Now let us move into the next hydrocarbon, hexane. So it has 6 carbon atoms and 14 hydrogen atoms. So this is the most simple one, straight simple chain. So we can name that as N-hexane. So we will do that at the end. So again I am going to find the isomers for this hexane. As a first, I will remove this methyl group from there and connect here. Then I have to remove this hydrogen and connect them. So you can see it become the CH2 group becomes CH3 because of this hydrogen attached here. Now I can shift this methyl group to here. Once I remove this hydrogen, there is a vacant available. So through that way, and this hydrogen should be applied. Now if I am going to change this methyl to here, then again I will end up with this structure. So there's no point of it because it will become the same isomers. So now I am going to take this isomer and change only part of this one. So what I am going to do is remove this methyl group and connect here. Now you can see it result new isomer. Now you can see it result again another isomer. So it is not equivalent to any of the isomers we drawn so far. So these are the 5 isomers in hexane, 2-methyl pentane, 3-methyl pentane, 2,2-dimethyl butane, 2,3-dimethyl butane. So we can understand that when the number of carbon atoms in the hydrocarbon increases, the possible isomers also going to increase.